Actually, there are two formulas that you need to know regarding circles. One is the standard form, so one is called the general form. Right. So in this slide, I'm going to show you how to derive the standard form. So let's start off by having a circle and also the coordinate axis. Let's label the x and y axis and also the origin 0. Right. So a circle, what determines the size of the circle? Right, the radius. And a circle has a center. So let's call this center of the circle A, B. Right. So it means that the x coordinates of this point is A, the y coordinates of this point is B. Right. So it means if I'm going to draw a dotted line from the center, a vertical line, okay, a vertical line from the center to the x-axis. So from here to here is A units. Okay, so likewise, if I draw a horizontal line from the center and touch the y-axis, so from here to here, you will have B units. Okay, so imagine that you have a little point P here. I'm going to use purple. Okay, you have a little point P here, and I'm going to call this point, I'm going to let the x coordinate of this point be x and the y coordinate be y. Okay, so what I'm going to do is I'm going to join I'm going to draw a line from the center of the circle to this point P. And what do you think that line is? Yes, of course, that line represents the radius of the circle, which I'm going to let it to be the symbol R. Okay, next I'm going to do is to form a right angle triangle. Why do I want to form a right angle triangle? Because if a right angle triangle is very versatile, I can use the Pythagoras theorem. Alright, so the next thing that I need to do is I have to determine certain length. That means I have to determine is the length from here to here. Okay, so we're going to do the same as what I've done earlier on for the point, for the center. Oh, sorry, I'm going to call the center, represent the center with the letter C. Right, so if we do the same, draw a vertical line down from point P and touch the x-axis, then from here to here, what you have is y units. Okay, likewise, you're going to drop a horizontal dotted line. Okay, touch the y-axis. Then from here to here, that will be y units. Sorry, I did wrongly. This one is x units, and that will be y units. Okay, so what we're going to do next is to find this distance. This distance here. So this distance will be x minus a units. And this distance here will be y minus b units. Alright, so we're going to apply Pythagoras theorem on this right angle triangle. And what is Pythagoras theorem? Pythagoras theorem is a squared plus b squared equals to c squared. Right. So the c squared is actually the sides that is opposite the right angle triangle, which is your radius. So that's equals to r squared. And then you can just let any of the two adjacent sides be a or b. So one of them is x minus a close bracket squared. The other one is y minus b. Okay, so basically we just found the standard form. This is called the standard form of the circle. Okay, And we use this standard form when you know the center of the circle. That means you're given the center and the radius of the circle. Right, then you use the standard form. So this is called the standard form. To do one example of what we've learned. To start off, let's write down the formula, the standard form formula. Okay, so the formula is this. Right, where A and B is the center and R is the radius of the circle. Alright, let's do part A. Okay, so you're given center 0, -4 and radius 5 units. And you asked to write down the equations of the circle. Leave your answer in the standard form. So specifically ask you to leave it in standard form. Okay, so what we can do is, if you were to compare the center, right, then you can see that A, right, A is equals to 0, B is equals to -4. So we're going to sub inside the standard form formula. So that will give us x minus A, which is x minus 0, square it, plus y minus B. Right, your B is -4, so it's y minus bracket -4, and you square it, and you're given radius 5 units, so that is 5 squared. Okay, if you simplify further, x minus 0 is x, so that will give you x squared, plus, this will give you plus, negative times negative is plus, so they will end up with y plus 4, and 5 squared is 25. Okay, so this is the standard form of a circle. Right, it's very easy. So you can do the same for part B. Write down the values of A. So in this case here, if you compare the center given with a C bracket A comma B, A is -9, B is -8. Alright, so you plug into the formula. X minus minus 9. Your A is -9, so it's X minus bracket -9 plus Y minus bracket -8 equals to the, oh, you're not given the radius, right? So never mind, we're just going to let the radius be R. So it goes to R squared. Alright, so if you simplify it, you will have X plus 9 squared plus Y plus 8 squared equals to R squared. Okay, so we will have to find the values of R. Okay, we cannot just leave the standard form in this way. So how do you find the values of R? So if you were to look at the questions carefully, there is one particular information that we have not made use of. And it says that the circle passes through that point. So what does it mean? What crazy? Alright, so what it means is that I'm going to use this circle. It means that on that circle, there's a particular point. Oh, I can't use that because it's -5, -7. Okay, so that means if there's another circle here, right, what it's saying is that there's this point here, -5, -7, somewhere here. Okay, there'll be a point somewhere there. Okay, where the x coordinate is -5, y coordinate is -7. So what do you mean by saying that this point passes through the circle? It means that this point satisfies the equations of the circle. which means that I can just substitute. Okay, I can just substitute x equals to -5, y equals to -7 into our equation 1 that we found early on. Okay, so that will give me -5 plus 9, -7 plus 8 equals to r squared. Okay, our purpose here is to find the values of r. So -5, so you can just use a calculator to work that out. Okay, I don't have a calculator, never mind. That will give me 16 plus 1 squared, which is 1, gives you r squared. So r squared is 17. So r is square root 17. Okay, so the radius is square root 17. So now we know the values of r squared. We can just plug it back into equation 1 and we'll have the standard form. Okay, so it will be x plus 9 squared plus bracket y plus 8 squared equals to r squared. We have found it here to be 17. So that's it. For part C of example 1, so you have a circle with the center -1 and 6 touching the x-axis. Okay, so we can draw a circle. Let's draw the x and y axis first. -1, 6, so it's -1, 6, so probably somewhere here. Right, and this circle actually touched the x-axis. Right, so when you say it touched the x-axis, that means your x-axis is the tangent. Right, it's a tangent line. Okay, so this one means the x-axis is a tangent line. Because the tangent line will only touch the circle at one point. So what it means is that from the center of the circle, right, if we were to draw a vertical line down, okay, wait, I'm going to write the center above. So if you're going to draw a vertical line down from the center and touch the x-axis, okay, this will be 90 degrees. Why is that so? Okay, recall this one we have learned. A tangent is perpendicular to the center of the circle. Tangent, this one you learn it in your angle properties. Tangent perpendicular to radius. Okay, tangent is perpendicular to radius. Hence, this will be your radius. So your radius is equal to 6 units. Okay, so with that, we can actually substitute into the formula. Right, so your A will be -1, your B is 6, and your R is equals to 6 also. Alright, so the standard form formula will be x minus A squared plus bracket y minus B squared equals to R squared. Okay, so let's plug it in. Let's simplify it. Okay, you have to simplify 6 squared as 36. You don't leave it at 6 squared. Okay, so this will be your standard form. Pretty easy. Alright, so far we have done some simple examples. We're given the center and the radius of the circle so that you can just substitute directly into the standard form formula. Or you have given the center at one particular point, and then from there you have to find the radius. So that's still manageable. We're going to do next is for other challenging questions where you're not given the center and you're not given the radius. But if you're given two endpoints of a diameter, right? So the questions to ask yourself is that what connects the diameter and the radius and the center of the circle? What does diameter means to you? Right, so diameter is actually twice of the radius. So 2 times radius, 2 times the length of the radius will give you the length of the diameter. Okay, that is one observation. Second observation is the diameter actually passes through the center of the circle. All right, so with these two observations, now we can go and work out our solution. So to find the length of the diameter, we will use formula. Okay, let's write down the formula first. So we're basically finding the length of AB. So the formula is this. All right, you have to make an effort to memorize it. And if you're not too comfortable about substituting inside directly, always label the point x1, y1, x2, y2. All right, so now we can actually substitute inside. So x1 is -3, minus x2 is 9, y1 is -6, minus 3. Please do not use a calculator to work this out because sometimes it may not give you an exact answer. You give you a lot of decimal places. So leave it in sets. So that will give you square root 225, which, yes, very lucky, it's an integer 15. But sometimes you don't get that right. So do not use a calculator to evaluate. Leave it in set, and then from there you apply the laws of sets to break it up. So if the diameter is 15, what can you say about the radius? Correct, the radius will be half of it, which is 7.5 units. Alright, so we have successfully found the radius of the circle. We still need to find the center of the circle. So from our second observation, we understand that the diameter actually passes through the center of the circle. And in fact, because the diameter is equal to 2 radius, okay, the center will be the midpoint of your diameter. Okay, your center is the midpoint of the diameter. So we're going to use the formula, the midpoint formula. So A will be equals to x1 plus x2 divided by 2. Gives you -6 plus 9 divided by 2. That gives you 3. B will be -6 plus 3 divided by 2. And that will give you -1.5. Okay, so with this information, you can just plug into the standard form formula. Okay, that will be y minus minus, so will be y plus. And 7.5, okay, I think it's better to leave it as 15 over 2. It's easier for us to square it. So square 15 is 225, and square 2 is 4. So you can leave the answer as this. So in part 1, we managed to find the equations of the circle and also managed to find that the radius of the circle is 7.5. So from the equations of the circle, let's write down the center of the circle. So the center of the circle will be 3. Comma -1.5. Alright, so for part 2, you're given the point. So we're going to let this point, we call this point A. So our job is to determine if this point A, whether it lies on the circle, inside the circle, or outside the circle. Alright, so besides the important things about some properties of the circle, one of them is the radius of the circle that determines the size of the circle. Another important thing is the center of the circle. The center of the circle is very important. Why is the center of the circle very important? Because that is the point where the diameter passes through, that is the point where the radius passes through, right? So we know the center of the circle, which is 3, -1.5. Okay, so if supposing this point lies on the circle means now on the circumference of the circle. Okay, if your point A is there. So what can you say about this distance CA? Correct, the distance CA will be the radius of the circle. So if you find the distance CA and if it's equal to 7.5, then we can confirm that this point A lies on the circle. Okay, and if we find this distance CA and if it's less than the radius of the circle, then it must be inside the circle, right? And if it's more than the radius of the circle, then what does it mean? It means it must be outside the circle, right? So the important thing now is to find this distance CA. So as usual, let's write down the formula. Right, so I mentioned this so many times, if you're not comfortable in substituting it directly, just label your points as x1, y1, and then this guy will be x2, y2. Okay, now we are ready to sub inside formula. So that will be 3 minus 11 squared. I'll bracket it first. Plus negative 1.5 minus 1 squared. So if you use this calculator to evaluate, I think you should get 8.38. So what does 8.38 tell you? Yes, 8.38 is actually more than the radius of the circle, that's 7.5. So therefore, the point actually lies outside the circle. Okay, so we need to explain it. Okay, so how do you explain it? So we say that since CA, oh, it's call this point capital, let this be capital A better. Okay, we need to be consistent. So since CA is equals to 8.38, which is more than 7.5, right? 7.5 means the radius of the circle, therefore this point lies outside the circle. Right, let's look at another type of questions that you may face in the exam. Right, and in this example 3, you're given the equations of the circle, and from there you're asked to find the center and the radius of a circle. So what I'm going to do now is I'll be showing you how to get the general form, but some people do not like to remember the general form. If you're very good at completing the square, then you can still find the center and radius from this given equations by adopting the completing square method, which I'm going to show it to you. But if you're not very good at completing the square, then it is very, very wise to learn the general form, which we'll do it at the next slide. So how do I apply completing the square here? So basically, I need to group all your x terms together. Alright, so I need to apply completing the square method to this. So I will need to add the coefficients of x, which is 6, divided by 2 square root. Now remember, this is an equation. If you add it on the left hand side, then you have to make sure you add it on the right hand side as well. Okay, and then the next thing is that I need to complete the square for this guy, which will give me, right, I need to add coefficients of y, it's 4. Don't worry about the negative, okay, just take the coefficients, the number. Okay, likewise, you have to add it at the other side as well. Okay, not to forget, I still got the plus 9 there. So this one will collapse into x minus 3 squared. Okay, the minus, you must follow the sign here. If this is minus and this is minus, here will be y minus 2 squared. Okay, equals to, okay, bring the positive 9 over. This will give you 3 squared, which is 9. 2 squared, which is 4, minus 9. So it gives you 4. Right, so you will end up getting the standard form of the equation. So from there, we can find that the center be 3, 2, radius equals to 2 units. Okay, so you use this method when you're very, very good at completing the square. Otherwise, it's good to learn the general form. So what is this general form all about? It's actually derived from the standard form. So let's write down the standard form first. It's just another way of presenting the equations of the circle. Okay, so I'm going to expand this guy. you get x squared minus 2xa plus a squared. Expand the other one. Alright, so what we're going to do is just going to group x squared and y squared together. And then I'm going to put all these constants. R is a constant, r squared. A squared is a constant, b squared is also constant. Put all the constants on the right hand side. Okay, so basically what we're going to do is I'm going to just replace all this constant with the letter C. Oh, wait, we don't do it this way. Wait, hang on. We just put all the constants together on the left hand side. Left hand side. So we bring that r squared over. Okay, so what we're going to do is we're just going to replace this guy with the letter C. And then we're just going to replace your x. No. You're going to replace your A, the center. Okay, we're just going to do it this way. Wait, hang on. Let me write it out. That means the center under the standard form is A comma B, right? So I'm just going to replace it. Replace your A with negative G. Replace your B with negative F. Okay, so this is what you get. You get a positive. You replace your A with negative G, then you will get negative 2x times negative G, give it 2gx. If you replace your B with negative y, you will end up with plus 2fy. Okay, and then of course, this one, you're going to replace it with the letter C. Alright, so the new formula becomes this, which is called the general form. Let me draw a line here. So the new formula has become this x squared plus y squared plus 2gx plus 2fy plus c equals to 0, where your center now becomes negative g negative f. Then how about the radius? How do you find radius then? Okay, so from here, we're going to make r squared the subject. So a squared plus b squared minus r squared is equals to c. So minus r squared is c minus a squared minus b squared multiplied by negative 1 throughout. So r will be square root. Okay, so this is called the general form of circles. So we'll do one example on it. So from the earlier slides, when we use completing the square, we managed to find the center of the circle to be 3, 2, radius 2 units. So now we're going to use the general form and see if we can get the same answer. So let's write down the formula first from the general form. So the formula will be x squared plus y squared plus 2gx plus 2fy plus c equals to 0. The center will be negative g negative f. The radius will be a squared plus b squared minus c. Now we have substituted the values of a to be negative g and b to be negative f. Okay, so that will end up g squared plus f squared minus c. Okay, I forgot to do that in the earlier slide, but you can just change it yourself. So let's do a comparison. Alright, so how do we compare? So x squared, of course, is comparable with x squared, y squared with y squared. So therefore, 2gx will be equals to negative 6x. Then your 2fy will be equals to negative 4y. And the value of c will be equals to 9. So you can break it up into 3 columns like that. Okay, so from there you can find the values of g, which is negative 3, values of f, which is negative 2, and you can find the radius, which will be negative 3 squared plus negative 2 squared minus 9 and that gives you square root 4, 2. So therefore the center it's equals to negative g negative f, which is equals to negative times negative 3 positive 3, negative times negative 2 positive 2, and radius equals to 2 units, which is the same values that you get when you apply completing the square method. Alright, so the choice is yours. If you're good at completing the square, then maybe you don't really have to learn this method, but you need to know that equate the circles have two equations, the standard form and the general form, and this is the general form. So in case if the question asks you to use general form, then you know you still have to learn it.